Jupiter, the mighty gas giant, looms large in our solar system, its sheer size and magnitude making it one of the most fascinating objects in the cosmos. Roughly 1,000 times larger than Earth and rotating once every 10 hours, Jupiter's turbulent atmosphere and ferocious Coriolis forces create winds and storms unlike anything we experience on our own planet. When one of the most celebrated astrophysicists of our time, Neil deGrasse Tyson, speaks about Jupiter, he does so with both awe and reverence. His ability to take complex cosmic phenomena, and explain them in ways that anyone can understand has captivated millions. And when it comes to Jupiter, Tyson's revelations challenge much of what we think we know, opening new doors to understanding not just this gas giant, but the very nature of our solar system. Jupiter's size is staggering. This colossal planet could fit over 1,300 Earths inside it, and despite being primarily composed of gas, it accounts for more than twice the combined mass of all the other planets in the solar system. Tyson often points out that Jupiter's immense size plays a crucial role in shaping the architecture of our entire solar system. Its gravitational influence is so powerful, that it is often referred to as the solar system's cosmic vacuum cleaner, pulling in comets, asteroids, and other space debris that could pose a threat to Earth. However, Tyson also cautions that while Jupiter's gravity protects Earth from some dangers, it also creates a double-edged sword. It can redirect debris in ways that send objects hurtling toward the inner solar system, potentially putting Earth at risk. This balance between protection and danger is part of what makes Jupiter so fascinating. The atmosphere of Jupiter is perhaps its most iconic feature. The Great Red Spot, a massive storm larger than Earth itself, has been raging for centuries. But Tyson reveals that this storm is just one of many atmospheric phenomena on the planet. Jupiter's atmosphere is a dynamic, ever-changing environment filled with powerful jet streams and layers of clouds that alternate between light and dark. These winds, reaching speeds of up to 400 miles per hour, are far more extreme than anything we experience on Earth, yet the underlying mechanics driving them remain a mystery. Scientists are still working to understand how these fierce winds and powerful storms are formed, and what they can tell us about the workings of giant planets. For years, scientists believed that Jupiter was composed entirely of gas and liquid, lacking a solid surface. However, recent findings suggest that Jupiter might have a solid core, though its exact nature remains unclear. This discovery has piqued the interest of scientists, including Tyson, who points out that the core could be rocky, metallic, or even something entirely unknown. Understanding what lies beneath Jupiter's thick clouds could provide critical insights into how gas giants form and how their atmospheres evolve. As Tyson explains, the more we learn about Jupiter's internal structure, the closer we get to unlocking the mysteries of planetary formation itself. Another awe-inspiring aspect of Jupiter is its magnetic field, the strongest of any planet in the solar system. This powerful magnetic field generates a massive magnetosphere that extends millions of miles into space, capturing charged particles and creating radiation belts that make the environment around Jupiter hostile to spacecraft and electronics. Tyson often marvels at this phenomenon, explaining that the magnetosphere is likely driven by the movement of metallic hydrogen deep within Jupiter's core. Metallic hydrogen is an exotic and rare state of matter that forms under the extreme pressures and temperatures inside Jupiter, and studying it could revolutionize our understanding of materials science and physics. Jupiter's magnetic field not only influences its own environment, but also provides a model for studying the behavior of magnetic fields on other planets, including distant exoplanets. Jupiter's moons are another treasure trove of scientific discovery. With at least 79 known moons, the planet boasts one of the most intriguing bodies in the solar system. Among them, Europa, Ganymede, and Io stand out. Europa, covered in a thick layer of ice, is believed to have a vast ocean beneath its surface. Tyson highlights that this subsurface ocean may harbor life, making Europa one of the most exciting targets for future space exploration. The possibility of microbial life existing in Europa's ocean is a tantalizing prospect that could redefine our understanding of life's potential beyond Earth. On the other hand, Io, the most volcanically active body in the solar system, is constantly reshaped by eruptions fueled by the tidal forces exerted by Jupiter's gravity. Studying Io provides a unique opportunity to explore geological processes that differ vastly from those on Earth, and it could shed light on the mechanics of volcanic activity on other planets. Ganymede, the largest moon in the solar system, is another source of intrigue. Ganymede has its own magnetic field and, like Europa, is believed to have a subsurface ocean, making it yet another compelling candidate for the study of extraterrestrial life. Tyson often emphasizes that Jupiter's moons are not mere satellites, they are worlds in their own right, each offering unique characteristics and the potential for groundbreaking scientific discoveries. While Jupiter's moons are captivating, the planet's faint ring system also deserves attention. Unlike Saturn's bright and prominent rings, Jupiter's are thin and composed primarily of dust particles. Discovered by the Voyager spacecraft in 1979, Jupiter's rings have puzzled scientists ever since. Their origins remain unclear, but Tyson suggests that studying these rings could provide valuable clues about the history of impacts and interactions in the Jovian system. The faint nature of these rings makes them easy to overlook, but they are nonetheless a fascinating aspect of Jupiter's environment. Perhaps one of the most revolutionary discoveries about Jupiter has come from the Juno spacecraft, which has been orbiting the planet since 2016. Juno's groundbreaking measurements of Jupiter's gravitational field revealed that its atmosphere extends far deeper than previously thought. This blending of the atmosphere with the planet's interior challenges the traditional models of planetary structure. Juno has also provided stunning images of Jupiter's poles, where massive cyclones swirl in geometric patterns, unlike anything seen on other planets. Tyson often expresses his amazement at these findings, marveling at the fact that the more we learn about Jupiter, the more we realize how much there is still to discover. Juno has also revealed new information about Jupiter's auroras, which are unlike those on Earth. While Earth's auroras are caused by the interaction between the solar wind and our planet's magnetic field, Jupiter's auroras are influenced by the particles emitted from its moons. This distinction offers valuable insights into how magnetic fields interact with charged particles, providing a deeper understanding of the cosmic forces that shape planetary environments. One of the most profound aspects of studying Jupiter is its role in the broader context of planetary systems. Jupiter is often thought of as a time capsule for the early solar system. Unlike Earth, which has undergone billions of years of tectonic activity, erosion, and other geological processes, Jupiter's atmosphere has likely preserved much of its original composition. Tyson explains that studying Jupiter's atmosphere is like peering into the past, offering a glimpse of the primordial materials that formed the solar system over 4.5 billion years ago. The discovery of ammonia and water vapor in Jupiter's atmosphere is particularly significant, as these compounds are thought to have played a key role in the development of life on Earth. Understanding how these materials were distributed in the early solar system could help us answer fundamental questions about the origins of life. In Tyson's words, Jupiter acts as a bridge between the small, rocky planets like Earth and the massive, star-like bodies that populate the universe. Though it lacks the mass necessary to ignite nuclear fusion and become a true star, its composition and characteristics make it a fascinating subject of study for understanding how celestial bodies form and evolve. The study of Jupiter, therefore, is not just about understanding one planet, but about unlocking the secrets of planetary systems across the galaxy. One of the most exciting questions Tyson raises is whether Jupiter could harbor life. While the planet itself is inhospitable, its moons, particularly Europa, hold incredible promise. Europa's subsurface ocean, hidden beneath a thick layer of ice, could provide the conditions necessary for microbial life to exist. The discovery of life on Europa would be one of the most transformative moments in human history, forcing us to reconsider the conditions under which life can thrive and expanding our understanding of biology beyond Earth. Jupiter's impact is not limited to the study of planetary science, it also holds cultural and philosophical significance. Throughout history, Jupiter has been a symbol of power, grandeur, and mystery, inspiring myths, art, and literature. Today, it continues to inspire wonder and curiosity as scientists and explorers work to uncover its secrets. Tyson emphasizes that the quest to understand Jupiter is not just a scientific pursuit, but a deeply human endeavor driven by curiosity, awe, and the desire to connect with something larger than ourselves. In conclusion, Neil deGrasse Tyson's insights into Jupiter reveal a planet that is far more than just a gas giant. Jupiter is a cosmic enigma, a dynamic, complex world that challenges our understanding of the universe. From its massive gravitational pull and powerful magnetic field to its intriguing moons and potential for life, Jupiter holds countless secrets waiting to be uncovered. As we continue to explore this giant of the solar system, we are reminded that the pursuit of knowledge is a never-ending journey, one that pushes the boundaries of science, technology, and human imagination. Jupiter is not just a planetary marvel, it is a linchpin for scientific discovery, philosophical inquiry, and technological innovation. As we continue to explore its mysteries, we gain a deeper understanding of the cosmos, and our place within it. The more we learn about Jupiter, the more we realize that it is not just a destination in our exploration of space, it is a gateway to understanding the very forces that shape our universe. Like, comment, subscribe.